Alright class, so we started talking about kinetics, and I went really slow because I want to make sure you understand kinetics. It's a hard topic before we move on to the next part. Now let's summarize what we talked about. So last time we talked about kinetics, and we said what kinetic is. Basically, kinetic is a rate of the reaction. Sometimes thermodynamic will tell us that a reaction will happen, but it doesn't tell us when it will happen, how long will it take, what's the speed of this reaction. And sometimes, for example, we talked about diamond turning into graphite. Thermodynamics says that reaction will happen, but kinetics says, well, sure, but it's going to take 1 million years, so that reaction is not very feasible. So kinetics is about rate of the reaction. Now, we said we measure the rate, we measure the speed of the reaction by looking at the change in concentration over time. Change in concentration over time. And that's how we are going to measure and look at kinetics over time. So basically, we can look at the change in concentration of reactant or change in concentration of product over time. But a better one is to look at the change in concentration of reactant, because at the beginning, you don't have much product, you have mainly reactant. And the last thing we talked about a rate expression. We talked about rate expression, and you wrote down the rate expression, which again was change in concentration over time. And now the last thing I want to make sure that you remember, we said the unit for rate is what? We said the unit for rate is molarity over time. Time, for example, could be second. Molarity over time. Alright, so this is what we talked about last time. Now let's continue. The next thing I want to talk about how we measure rate using a graph. Okay? How we measure rate using a graph. So right here, I have a graph. Concentration versus time. My time is hours, concentration is molarity, that's what we want. And I ask you to find instantaneous rate at 23 hours. Now let's go over how you would do this. I'm going to break it down into steps, okay? Step 1, what do? What are you going to do? You are going to draw a tangent line. What's a tangent line? What is a tangent line? A tangent line is basically a straight line that touches 23-hour point. So I want you to look to find the rate at 23 hours. So draw a tangent line. So tangent line is a straight line that would touch the 23-hour point. You guys are following me so far? Okay. So I'm going to come over here. And this is about the 23 hour is right here. This is my 23 hour, okay? And I've already drew a tangent line because it was really hard to draw it on my iPad. So I had to redo it. So here's a tangent line. So tangent line is a straight line that touches the point that you want. Here is a 23-hour point. This is my 23-hour point. The tangent line is a straight line that touches that point. We're good so far? Okay, so that's number 1. Now, number 2, so after you draw a tangent line, which is a straight line that touches the point that you want, then what you have to do, you have to find the slope. You have to find the slope. And you know how to do that. But I'm going to go over it anyway because I'm making to make sure we're all on the same page. How would you find the slope? To find the slope, you need 2 points. Do you guys agree? So you're going to find 2 points on that line. Doesn't matter which 2 points. Make points that are easier to kind of do the calculation. So you are going to find 2 points on this line, okay, on a tangent line. Let's say I'm going to do 1. So we're going to do 2 points on this line. I'm going to do 1 here at 38 hours, okay? That sounds good. And then I'm going to do 1 over here at 1 hour. You following me so far? So I just got 2 points on a tangent line. And you know how to find the slope. It would be y2 minus y1 over x 2 minus x1. That would be the slope. Okay, now let's go over here. Again, this is not the best graph because I'm just doing this on a whiteboard, but you get the idea. So the y would be, this is y, the concentration, and the x is the time. So I'm going to go this one first. It doesn't matter which one you do first. So 38 hour, and if I go 38 hour, that is about probably 0.08. That is about 0.08 molar, okay, minus, now my 1 hour, so this was my 38 hour, minus, now my 1 hour, what is about 0.4, is about 0.4 minus 0.4 molar over 1. You follow that? Okay, so I drew a tangent line. This is a 23 hour. Let me write this out. So this is a 23 hour. I drew a tangent line, which is a straight line that would touches the point that I want. You following me so far? Step 1. Step 2, find the slope. You know how to find a slope. You find 2 points on that straight line. Okay? You find 2 points on that straight line. y2 minus y1 over x2 equal minus x1. Okay, so my y will be my concentration. So 38 hours minus 1 hour, and I have to find the concentration. 38 hours, the concentration is about 0.08. 1 hour, the concentration is about 0.4. Yeah, okay. Now, if you put this in a calculator for me, what do you end up getting? You end up getting negative 0.00865. Okay, that is going to be your slope. That is going to be the slope. Okay, now what is the unit of this slope? This is really matters. What is the unit of the slope? It would be molarity over hour. Molarity over time. Well, guess what? Wasn't that the unit for rate? Yeah. So we just use a graph to be able to do this. All right. Nice job. Now that we know this, the next thing to talk about, we're going to talk about effect of concentration on rate, because concentration matters, right? You've seen this. Concentration matters, and we even look at concentration over time to figure out rate. So we're going to take a closer look at the effect of concentration on rate. That's what we're going to do. Now, one thing that you already know is that if you increase the concentration, what happened to the rate? You already know that. If you increase the concentration, the rate is going to increase. You know that, right? Then the reason for that is if you increase the concentration, it's going to be easier for the atoms to find each other because there's more of them, right? There's more of them. If you go to a school that has a lot of kids, it's going to be easier to find friends, right? Because you have more people around you, so it's easier to find someone. It's the same thing here. You have more atoms around you, it's going to be easier to find atoms and be friends and react. All right. Now, what we're going to do, we're going to write a rate law. We're going to learn how to write a rate law. A couple things about this rate law. Number 1, you find it, this is really key, by doing experiments. So you find the rate law by doing experiments. You cannot just look at the reaction and say, probably that's the rate law. No. You're going to go to lab. You're going to put in the time and do the experiment. And the way we do a rate law, basically what we do, we measure rate at different concentrations. to figure out what is the rate law. Okay, at different concentration, we're going to measure rate. All right, so far so good. All right. Now I'm going to add one more thing. And rate law is basically mathematical. I'm going to write everything down. Just make sure you're on the same page as me. It's a mathematical equation that relates concentration to rate. Okay, so now let's summarize it. I haven't talked about it. So to find a rate law, you can't just look at an equation and say, this is what I'm feeling right now. You have to get in lab. You have to do experiment. Now, this is very key. That basically what rate law is a mathematical equation that relates concentration to rate. Basically what happens to the rate when you change the concentration. So it relates concentration to rate. And you have to figure it out by doing experiment. All right, you ready to do this? Let's do this. Let's say, for example, I have A plus B going to C plus D, okay? And I'm going to write a rate law for this, okay? Now, we write the rate law. We are going to write the rate law based on the reactant only. So we write the rate law based on the reactants only because we start with the reactants. You follow me so far? Good. So rate is going to equal K times the concentration of A times the concentration of B to the power of M to the power of N. So rate is going to equal concentration of K, equal K times the concentration of A times concentration of B. Now, what is K? K is rate constant. Is rate constant. Now, a couple things I need you to remember for K. What K is unique for each reaction. So K is unique for each reaction. So if you have a reaction, it has a K. And this is really key, that the only thing that would change is it changes with T. It changes with temperature. So what that means is temperature dependent, is T dependent. So far so good. So K is a rate constant, is unique for each reaction. Each reaction is going to have a rate constant. And K, the only thing depends on temperature, is temperature dependent. Okay. Now, you know the bracket means concentration of A and B. And one more time, we do rate law based on the reactants. So we do rate law is what? I'm going to write it down. Based on reactants. Now, the last thing you're probably going to ask me is like, well, hold on a second. What is this M and what is this N? What those are reaction orders. Those are reaction orders, okay? Those are reaction orders. And the overall order would equal M plus N. The overall order would equal M plus N. Okay? All right, beautiful. Now, I want to do an example right now to show you something. Again, don't worry, we're just starting this. Going to 2FClO2. Here is my chemical reaction. Okay? If I were to write, I'm going to write the rate law for this. Rate law for this reaction is equal K times concentration of, do it with me, F2 times concentration of Cl2. And I've already looked up this rate law is to the power of 1 and is to the power of 1. Okay, so this is, I looked it up, this is the rate law for this reaction. Now, what does this mean? What does this mean? This is really key. This means that the reaction orders are not related to the coefficients. I looked it up. So I looked up this rate constant. Then I need you to remember, and I need you to write it down and highlight it and then circle it and then take a picture of it, that the reaction orders are not related to the coefficients. The reaction orders are not related to the coefficient, because if they were related to coefficient, this would have a coefficient of 1 and this would have to the power of 2, right? If they were related to the coefficient, this would be to the power of 2, but it's not, it's 1. I looked this up. So I'm going to say it one more time. You can repeat after me, that reaction orders are not related to the coefficients. Okay, we'll show you in a second how to figure it out, but this part I need you to understand. Okay, now let's figure out how to find out the reaction orders. So now that we know that the reaction orders are not related to coefficients, the next question you're probably going to ask me is, how do we experimentally, because you know you have to do experiment to figure out the rate law, how do we experimentally determine the reaction orders? This is what we're going to go over now. But the key is, experimentally, you have to do this. And what I'm going to do, I'm going to put up a chart. Give me 1 second. Okay, so here is a table. So someone went to lab and they did this experiment. Okay, now what we want to do, we want to find out a rate law. We want to write a rate law for this reaction. We want to write a rate law for this reaction. Now, you can do the first part without me showing you how to do the orders. Let's do this together. You doing it with me? You're going to write down that rate is equal what? Equals K, that doesn't change, concentration of A times concentration of B. Now, what we need to figure out, we need to figure out what are the orders. What is M and what is N, right? We need to figure out the orders. And how do we get the orders? We have to do experiment. We have to do experiment. You ready? Okay. Pay attention. Let's look over here. I want you to look at experiment 1 and 2. Look at experiment 1 and 2. If you look at experiment 1 and 2, I like experiment 1 and 2 because the A doesn't change, the B changes. One thing you need to realize, that when you are figuring things out, anytime in sciences you're trying to analyze a graph, you can never have two variables. If two things are changing, that's not going to get you anywhere. One thing has to be changing. So I'm going to choose experiment 1 and 2 because A is not changing and B is the only thing that is changing, so I can figure out what's going on with B. So only one of these has to be changing. Otherwise, you can't really know what's going on. One variable at a time. So what's going on in B right here? If you look over here, the B concentration, what they did, they went from 0.5 to 1 molar. They multiplied it by 2. Do you agree? Now, what happened to the rate when they double the concentration? The rate also doubled, didn't it? That's cute. Okay. So, I did experiment A because the A concentration doesn't change. That's great because you can have more than one variable. Okay? Now, what happened is the concentration of B doubled. And when the concentration of B doubled, what happened to the rate? The rate also doubled. Okay? So the rate also doubled. Now, what does that mean? If you double the concentration and the rate also doubles, what that means is, that means you are first order reaction. That means you are first order reaction. Yeah? Okay. Now, tell me which two experiments should we look at? now what we want to look at what happens to A. We should probably look at experiment 1 and 3. Do you agree? Because if you look at the experiment 1 and 3, you see that B stays the same. Again, you can only change one variable at a time. So this is great because the concentration of B doesn't change. It remains the same. Okay? You guys agree with that? Let me write this a little bit nicer. It doesn't change. Now, what happens to the concentration of A? Look at the graph for me. Let's look at the concentration of A. So B nothing happens to B. If you look over here, let me use a different color pencil so you don't get confused. I can use a different blue. How about that? So what happened to concentration of A? Even from 0.5 to 0.25. A got down is divided by 2. It halved it. Do you agree? Okay. So again, B remains the same. That's the whole point. So when they halve the concentration of A, what happened to the rate? Nothing happened to the rate. Isn't that interesting? Nothing happened to the rate. So what they did, they made the concentration of A go down by half, so multiply by 1/2, right? But nothing happened to the rate. Nothing happened to the rate. When you change the concentration, this is key. When you change the concentration, but nothing happens to the rate, you are a zero order. Because that means the concentration doesn't matter. The A does not affect the rate whatsoever. So I changed the concentration of A, I made it half, and nothing happened to the rate. The rate remains the same. So what does that mean? That means the A concentration does not matter. It does not affect my rate. Do you guys agree? Okay. So now let's do this. What is going to be my rate law equation? K is equal A to the power of 0 because it was zero order, and B to the power of 1, and B to the power of 1. Now, what I could do now, I could just cross out A, because A goes to the power of 0. It doesn't matter. It doesn't make any effect whatsoever. How do you guys feel about this? Not bad? So, let's kind of summarize this quickly. So, to do a rate law, and let's go here. Rate law is going to be based on the reactant. You go rate equals K, which is the rate constant, times the concentration of the reactant to the orders. The orders are not the coefficients. The orders are not the coefficients. How could you figure out the orders? You have to do experiment. Here is the experiment that I put up over here. To figure out the orders, find 2 experiments that only one thing is changing. You cannot change 2 variables at a time. That would not be good. And then figure out when you change the concentration, how does the rate changes. If it doesn't change, that's 0. You can cross it out. If you double the concentration, the rate doubles. That's first order. So that is my equation. That is my rate law. So far, so good? Okay. Now, let's do one more practice problem with this. And then you deserve to take a break. Solve for K. I want you to solve for K. Okay? Now, to solve for K, you can pick any experiment and just plug in the numbers. So to solve for K, you can pick any of the experiment 1, 2, or 3 and plug in the numbers. What I'm going to do, I'm just going to pick experiment 1. You could have done any of them. It doesn't matter. Okay? Now again, remember that rate is going to be equal K times concentration of B to the power of 1. Again, don't get confused. I just crossed that A because A is to the power of 0, so it doesn't matter. It's not going to make any effect. So far, so good? Okay. Now, for experiment 1, what is my rate? The rate is 0.010. Okay? So the rate is 0.010. I don't know what K is. I'm going to go back here. What is my concentration of B for experiment A? Is 0.5. So is 0.5 to the power of 1. Okay, now what I'm going to do for K, I get 0.02. Now here's what I want you to do. Tell me, I know I can't hear you, but I want you to tell someone next to you, even if they have no idea about chemistry, what is the unit for K over here? What is the unit for K over here? Now, remember, rate, the unit for rate was what? The unit for rate was molarity over second. I have it right here, molarity over second equals, you have K, and B is the concentration, is the molarity, right? Times concentration, which is molarity. So what is going to be my unit for K? My unit for K has to be 1 over S, because 1 over S times molarity would give me molarity over time. So this one would be 1 over S. This one would be 1 over S. Sounds good? Okay. Nice job. Really, really nice job. And before I let you go, I want to give you a practice problem to do. I want to put up a practice problem. Do this at home. And then next time we're going to start the lecture with that practice problem. Here is a practice problem. Here's a take-home problem. What I want you to do, and don't do it today. Do it like tomorrow. I want you to take a break to see how much you remember tomorrow. Write the rate law for this. Write the rate law for this, okay? And these are the experiment, these are the reactant, and how they change their concentration, and then what happens to the rate. Sounds good? Okay, do this problem for me. Do this problem, and I will see you guys next time.